So I recently had to use GPT-4 Vision on a smaller project I was working on, and man, it inspired me. I just thought of so many different ways that I could apply GPT-4 Vision to business automations. And because of that, I decided I'm going to build out a full playlist here on the channel, taking you guys through multiple different projects and step by step on how to code them out. And this is going to be the first video in that series. I suspect that this series will be anywhere from 10 to 20 videos, and I'll be uploading a video every week or every other week on this specific topic. But if you are new here, I do have a lot of other videos on OpenAI as well as LangChain, and I'd recommend that you start there before you jump into GPT Vision, although you don't necessarily have to. All you have to have is like a basic understanding of Python, and I think you should be pretty much good to go. There's going to be a few things that we are going to need, and I'm going to jump on my computer right now and walk you through them. All right, so to start off, let's make sure we go to openai.com and log in. So make sure you go to the API side of things. The first thing that you're going to do is to create an API key. So just go over here to create new secret key, name it whatever you want. So I'm going to just name it this. I just typed in some random letters and create secret key. This is going to be blurred out so you can't see that specific key, but make sure you store this somewhere because you only can access this key once. Now, no big deal. You can always generate more keys, but that's essentially what does happen. And I have covered this in another video, so that's why I'm kind of speeding through this. All right, so now we want to jump into our usage side of things. And what we're going to want to do is add in a payment method. Now, by default, OpenAI gives you $5 to use, which is great. But to use our GPT-4 Vision, you're going to have at least 5 more additional dollars added to your account. You can't specifically use this with just a free account with that free $5. So add in your own specific payment method and add $5 there, and then you should be good to go. Now, you might get an error message for like the first hour or 2 hours after you add that $5 in. I did for my first time. So feel free to pause the video and come back here later this day or come back tomorrow when your account is refreshed. Now, the other thing I have read is if you have an upgraded ChatGPT account associated with your OpenAI API key, you can disregard that $5. But personally, I don't have that upgraded ChatGPT account, so I have not tested that. I just added the $5, and I know it took me a few hours to get my account changed over where I could use this specific model. You'll get an error message specifically in Google Colab or whatever editor that you use that says that this model is not available. Otherwise, it is available, but you just have to add the $5 to your account. All right, with that being said, let's start coding. All right, and also real quick before I do code, if you want to see essentially what the source code of this video is, I am making a few minor changes, but I'd say 99% of it is here. Platform.openai.com/docs/guides/vision. I think this is a really great way to start with this. And let's get coding. So I am going to personally use Google Colab. Feel free to use whatever you like. I just prefer this for tutorial sakes. So the first thing that we're going to do on here is we're going to have to pip install OpenAI. Kind of a pain. We always have to do this, but that's just something with Colab right now. So make sure that you pip install that. All right. So next thing, what we're going to do is from OpenAI imports OpenAI, and then run that. We'll drag down to the next line. We're going to import in OS, and then we're going to set up our environmental variable for our API key. So I showed you guys where you can get that API key from. So os.environ over here, and then just throw your OpenAI API key here. So OpenAI underscore API underscore key, oops, and then equals. And remember, this is supposed to start with SK, and then your key is over here. I'm going to paste my key and then just remove it from the video, but make sure you put your key in here and then just run this cell. All right, so what we're going to do is we're going to start off with a web-based image because I think this is going to be the easier one to use example-wise. So the first thing we're going to do is set up over here clients, and that's going to be equal to our OpenAI like this. Okay, run that line. And the next thing we're going to do is create a bunch of JSON. So I would recommend that you just copy this because it's going to be a little bit faster. So we'll just go through all of this really quick and grab that specific code, and then I will paste it down below. So what we're doing is creating a response. So we're doing client.chatCompletions create. then we put in our model. So right now we're using GPT-4 Vision Preview, and that's been working really well. But if you are in the future and they have GPT-5 Vision or another version of Vision in the future for GPT-4, feel free to change that in this model section. So now we have this messages section. So we have a role, which is a user. So you don't need to change that. But then we have this type over here. So we have text, and then the text we're saying is what's in this image. Now, you can specifically change this text, and I'll be showing you how we can change this a little bit in the future, but that is there. So next side of things is we have this specific type. This one, we're going to be using an image URL, but on this one for the type, we're going to be using image URL. And we are also going to be using image URL when we upload our own specific files. So just keep that the same. So next, what we have over here is our specific image URL. I don't want to use the example that they gave us. I'm actually going to go through two different examples. So I'm going to copy over my first link, and I will show you what that is as well. And then you can just see everything else is closed out. The last thing that we have over here is our max tokens. So they're just essentially the max tokens that we want to specifically use for this run. So really quick, this first image that I'm going to be using is actually this album that I have in the back. I know I'm small in the corner, so you probably can't see that. But one of my favorite albums out there, this is by the one and only Billy Strings. So I want to see specifically what happens if I upload this to GPT-4 Vision. And feel free to use whatever image you want. I am just going to use this one over here. And I'm going to click over here and run this. So it'll take a little bit to run. And now that it is complete, if we want to see our specific response, we can just go over here to print, and we can say response over here dot choices and populate our 0 over here. And you can see choice, finish, reason, stop, index 0, log props, message, and then it says content. And this is what we're going to be specifically looking for. This is our response to this image that we applied over here to the GPT-4 Vision preview. Said, this is a colorful abstract art image. It features a complex array of images, lines, colors, and woven to create a visually simulating piece. The style is reminiscent of modern or contemporary art, where the arrangement and combination elements may not represent a specific real-world objects, but rather an aesthetic experience or emotional reaction from the viewer. And it just talks about the album itself. Doesn't know that it's a specific Billy Strings album. I guess it's not a bluegrass fan. No worries. But let's take a look at another example. So what we're going to do is take a look at what many people consider kind of the holy grail of baseball cards. And that right here is this Honus Wagner, the T206 Wagner. One of the most expensive cards. In any grade, this sells for well over $1 million. So let's grab this image URL. Again, we just grab these from specifically Wikipedia, but you can grab this from wherever else on the web. And I'm just going to paste this in here, and I'm going to rerun this. Again, it'll take about 30 seconds to a minute, and I will see you guys then. All right, and I'm going to just rerun this response. So again, we have all this information over here, and it says, this image features a vintage baseball card depicting a man wearing the word Pittsburgh. Well, this is interesting, right? What essentially is happening is our vision is detecting text on this image, and it's extracting. Now, we're not going to cover this fully in this video because I have another few videos planned around this, but this is pretty cool, right? We can grab text in these images. All right, let's keep going through. The card represents an era where baseball cards were a popular collectible and often included in tobacco packaging. The card includes a name at the bottom, which is right there, which is part of the design. But I will refrain from mentioning the specific real-world identities, which is kind of weird. Surprised I didn't say it's Honus Wagner. The design is now indicate it's early 1900s. Well, this was produced from 1909 to 1911, so pretty close, considering the spelling of Pittsburgh without the H, which is how the city was sometimes spelled historically. See, I did not know that, but that's actually really interesting. Wow, I didn't know that. Baseball cards like this are often highly prized by collectors, especially when featuring notable players from that time. So that gave us a ton of additional context on this T206 Honus Wagner baseball card. All right, so let's go through our next example now. And what we're going to do is take a look at a local image. And local image being something that you already have on your computer. So the first thing, we're gonna have to bring in two imports. So we're gonna import in base 64 and we're gonna import in request. So import in both of these over here and just run that cell, bring a new cell down below. Now, there is a function that has been supplied to us when we're using specific local images. So this define encode image. So we'll populate this over here. So what we're doing is taking a look at this image path and then we're returning the base 64 encoding based around that. And basically what the documentation says is if you're going to be grabbing a local image, it has to be base 64 encoded directly within the request. And that's what we're going to be using with this function. So open image path is image file, return the base 64 encoding image file to read, decode, and UTF-8. So that's what we're using over here. Run that as well, and we will keep on going forward. So the next is what we're going to do is grab our image path. So image path, and we're going to say that's going to be equal to wherever our image is. Now in Google Colab, you don't have to do anything too special. You just have to drag and drop an image over here. So I will be doing that. I already have an image over here, and let's grab that. You'll get this message that the files are going to be deleted after. So make sure you just save your file somewhere else if you do need it. And just a shortcut, just rename this file and populate it over here. The file name is Western States Endurance Runner JPEG. Let me just show you what this specifically looks like as well. So we just have a runner over here supporting the Hoka brand, Hoka shoes as well, I believe. But he's in the middle of a trail race, which is the Western States 100. It's kind of like the Boston Marathon, essentially, of ultra running. A lot of people really want to run this race. It's super historic. I want to eventually run it too, but I'm not really good as a mountain runner, and I'm not in the shape to run the Western States 100. I'm training for my first 100 still. But regardless, that's the image that we're going to be taking a look at in this specific example. So just run this image path. I'm just also going to remove this over here to the side so that way you guys don't need to see that over there and we can see a little bit more code. All right, so now what we're going to have to do is actually encode this image. So what we're going to say is base 64 underscore image, and that's going to be equal to encode image. And what we're going to do is populate this image path. So again, what this does is it runs through this function that has already been generously supplied to us. So all we have to do is essentially bring this image that we have over here in Colab, and it's going to run this function. So we run that over there and boom, it's now a base 64. Awesome. So next thing we're going to do is create a header. But before we do that, I'm just going to create something called API key. And we're going to say that's equal to our os.environ that we set up earlier, and just put in here OpenAI API key, just like that. And you should be good with that because now we're going to set up this headers. So headers like this is going to be equal to, and inside over here, we'll set content type, and we're going to say application. Oops, this needs to actually be in quotes, but application JSON, the world's best spelling of application. Coding and recording at the same time is a little bit harder than you guys think, but roast me, go ahead. But anyways, we're going to put authorization over here, and again, just directly from the documentation, put error, and we're going to put our API key, just like that. So our API key that we have over here is getting fed to this header. All right, so we're going to bring in a little bit more of this code. So what we have over here this time is payload. So we'll grab that in and we're going to populate this right over here. So payload, model GPT-4 Vision preview, which is essentially what we had over here, right? If you take a look at this, we have our model first, and then we have our messages this time. Instead of just a message, we actually have messages like this, but this time we actually put this in quotes. And then over here we have role user and then content type. So this time we have type text, what's in this image, okay? And then type image URL. And this time with the image URL, you're populating URL. You have this over here, image/JPEG, base 64, and then we populate this base 64 image which we have over here, that encoded image, which again goes through this function, creates the base 64 image. We have this header over here, and then we also have this payload. All right. So now we just run this payload over here. I believe we didn't run this headers, so we're going to run that as well. And again, also, if we want to specify our max tokens, that is also available. So finally, what we're going to do is create our response. So response equals, and we're going to put requests over here dot post. Then what we're going to do on this side of things is we're going to put a specific link, and I will just copy that so I don't mess that up. But HTTPS API openai.com/v1/chat/completions. Then what we're going to say is headers equals headers. And then JSON is going to be equal to this payload. JSON equals to payload like that. We're going to run this line. It's going to take a little bit. I will fast forward once this is run. Okay. And one more line just to make sure that we get this working. Just so print over here, do response.json like that. And response, not response, response. Run that. And if we scroll over here to the right, this image shows a trail runner in mid-stride running through a mountainous landscape at what appears to be either dawn or dusk, given the soft lighting and long shadows. The runner is equipped with typical trail running gear, including a visor, sunglasses, a technical running shirt, compression socks, and brightly colored trail running shoes. See, additionally, the runner is wearing a race bib numbered 15, indicating participation in an organized trail running event. The environment is characterized by a grassy landscape with low shrubbery and a few scattered trees, hinting at a high altitude, essentially like that. And yeah, amazing amount of detail just from that specific image. All right, and real quick, one other thing I wanted to share with you guys before we jump into this last example. We do have an opportunity to specify how detailed of an image that we want to feed into the model. So what we can do is specifically under this URL, on this image URL, we can just add in a new line. And there's 3 options on this. So you just want to call it detail like this. And inside over here, you can populate either high detail, you can populate low, and by default, you're going to do auto. So I just wanted to share with that. If you want to specify your detail, so that way you can save some tokens if you want to put it in low and kind of test it, but it just depends on your use case for using in GPT-4 Vision. I personally just have it as auto right now, but I may change that in the future depending on a project. All right, so now that is covered, I'm sorry, again, I didn't put this at the very top. What we're going to be doing is we're going to compare 2 images. Compare 2 images. All right, so let's talk about how we can do that. And I'm just going to drag in my specific code over here, and we'll go through it. All right, so same exact thing with this response. So client chat completions create model over here, and then messages. So role user the same. Context, content this time. So the first side is type text. I changed this text over here and said, what concert is at night? So we're going to be taking a look at these 2 images, and we have to see which one of these 2 is at night. So this first one over here is a band called Black Label Society. Zakk Wylde, who was the guitarist also for Ozzy Osbourne, Pantera right now, right? We can see that this is a daylight concert. I believe also this image over here is back when this was, well, this is Welcome to Rockville, by the way, was at Jacksonville. And our second image over here, if we grab this one, this is 9 Inch Nails at Rockville, which sadly had some technical difficulties and did not play one of my favorite songs on their set list. Song they barely play. But regardless, it was a phenomenal concert seeing 9 Inch Nails, and I've been lucky enough to see them twice. All right, so obviously the second image, this 9 Inch Nails is at night. 9 Inch Nails doesn't play during the day that often, but this is night. You can just tell with how dark it is. This is the day. But we're going to be feeding this to GPT-4 Vision and seeing if it can determine which one of these concerts was at night. Now, so same thing, type image URL. This time we're specifying the image URL for each of these, so we don't have to go through all those extra steps. And we're also specifying our max tokens of being at 300. So I'm just gonna go over here and run this. And lastly, we're gonna print out our response. So response.choices 0, and my typos today are all over the place. But we have this over here, and it says the second image depicts a concert being held at night. You can tell this by the fact that it's dark and artificial stage lighting is being used, which is a characteristic of a nighttime setting for a concert. The first image shows a concert taking place during the day, as evidenced by the natural daylight and the clear visibility of the sky above the crowd. So it knew exactly what was going on. So let's just recap this video one more time. So just going through this, right? If we want to have the GPT-4 Vision use a specific image, it is much easier if the image is already specifically online, because we don't have to do a base 64 encoding of that. So just grab that image URL and then populate it within this JSON that was created. So you can grab this source code specifically from the Vision documentation online, but we have this response over here. We populate our model, then we fill out these messages over here. Feel free to change this specific text, but by default, it's what's in this image, by default, meaning what I grabbed from the documentation. And then we upload in this image URL, the URL. Now, if we want to upload a file specifically from our own system, we are going to have to take a few extra steps. First thing is we're going to have to make sure that this is base 64 encoded, which we have this function that we can specifically use. Make sure you call the path to that file. Then we're going to run that function on that file. Then we're going to create something called a headers. So that way we can have our API key in that header. Say it's application JSON. Then we have our payload, which is very similar to what we had over here in this response, but just a few small tweaks. And then our response this time includes this link, API OpenAI completions, and then includes also our headers as well as our JSON payload. And that is our response this time. And then we can just print out our response.json. We can also compare two specific images if we wanted to. It would be kind of cool as another test case to see if an image was photoshopped or not, which may or may not be another video in the playlist I'm developing. We'll talk about that in the future. But regardless, we have that over here. I just wanted to see what was during the day, what was during the night. And lastly, if you want to specify the size of the image, you can go over here to detail. High is going to be your highest quality, low is going to be your lowest quality. And then I just personally use auto, which you don't need to specify before running this code. So that's about it. So if you guys are able to follow along and utilize GPT-4 Vision, it's a pretty cool technology, isn't it? And if you were able to enjoy this video and code along, make sure to subscribe. I'm uploading multiple data videos every single week on this channel as I try to improve my data skills and share it along the way with you guys. Now, I will have more videos on GPT-4 Vision in the future, and you can check out that playlist right over here once that is created. But I do have a lot of other OpenAI and LangChain videos, but you can check those out over here as well.